Hi everyone, it's me again here to discuss about the dictionary or our ADT based on set, which is the dictionary. So remember in our previous discussion, as a refresher, we discussed about dictionary, which is a set ADT with the operations insert, delete, and member. We also include operations initialize and make null, and this is mostly used in database management systems. For operations, we have insert, delete member, and utility functions, initialize, and make null. Those are pretty self-explanatory, but they can be implemented by something called hashing. We know linked list, we know array, we know cursor based. So what we will be discussing about is hashing. And we had a quick discussion about the hash function, which is just a function that determines where the element is going to be stored or the starting point where the element is going to be found. So we discussed about open hashing as well, which is the set stored in unlimited space. Potentially is the keyword, mainly because it's determined by the amount of memory your computer has. And this was an example of open hashing, an array of linked list. So given our set A, we wanted to store all of these elements into our array of linked lists. And the hash function is what determines where each element is going to be stored. And if you can recall, the hash function in this specific scenario takes the ones digit and stores it at the index of the ones digit. So 0 is stored at index 0, 13 is stored at index 3, 20 is stored at index 0, 28 is stored at index 8, and so on. So once all of the elements have been inserted, you will notice it's all based on their ones digit. 45 has a 5 as the one, so it's stored at 5. So the data structure for open hashing is represented as an array of sets, meaning any way that the set can be implemented, we can use open hashing. Each set can be implemented using an array or a linked list. In this specific example, we're using a linked list. But you could also have an array of circular arrays. So that's something that you can do as well. And so we had a couple of exercises. We discussed how to accept an integer as parameter and returns the digit in the ones place. Or we had a hash that converts the first letter of the last name to an index. We also know how to do that, which was like this. And we had a quick activity wherein we discussed how we could do other kinds of hash functions. You also had an assignment, guys, of writing the structure pointer to the structure and the specific dictionary. So you wanted to write the appropriate data type for what this looks like. And I left that to you. Nobody has submitted that so far, but we were supposed to discuss that in person on last Wednesday. Unfortunately, because of the earthquake, we couldn't do that. So let's save that for when we can meet face to face, and let's just move on. So this would have been a continuation of what we were doing. So given what you have provided, the structure, the pointer, and a dictionary, we were supposed to start by doing initialize dictionary, and we were supposed to start practicing how we were to insert, delete, and find a member inside our program that we were supposed to code. So let's leave these coding activities to you guys. So you guys can start doing these coding activities at home and try to practice with open hashing. We will check that next week. If you have any questions, please do feel free to send me a chat on Gmail, and I will be able to provide you feedback pretty quickly. Things to think about. So if the hash function evenly distributes n elements, so let's say if my hash function evenly distributes 100 elements into, let's say, 5 groups, how many on the average is the number of elements in each subset? You would know how to calculate that, right? What is the running time each of the operations insert, delete, and member? What is the effect if all n elements are assigned to one subset only? So this is something you can think about. I won't give you an answer right now, just try to ponder. What if I have 100 elements and I'm splitting that over 10 groups? How many will be the number of elements in each subset? What is the running time? And what happens if all elements are in one subset? Just try to visualize this. So now, let's discuss about something we haven't discussed previously, which is closed hashing. So closed hashing is a bit different. So in closed hashing, we represent the dictionary not as an array of sets, but rather we will be storing each element inside the specific array in the dictionary. So given a set A, B, C, D, E, and F, and a hash that I actually don't know what these hash values do, or this hash function does. So it doesn't even matter what the hash function does. What matters is that it gives me a value, and it gives me the value where the specific element is to be placed, or a specific index where the element is to be placed. So for example, I'm calling the hash function, and I am going to insert the letter A. So hash of A returns a 3, therefore A was stored in index 3. Again, I'm trying to insert character A. So to insert character A, I need to do a hash of A. The hash of A returns a value 3, so it's now inserted at index 3. We'll do that for the next few elements. I'm going to insert B. So I'll hash the value of B and it returned an index 9. Therefore, B was stored in 9. Similarly, insert character C. Hash of C is 4. So I inserted C at index 4. Very easy, very straightforward. Now the problem comes when you try to hash a value that already exists. So for example, insert the letter D. Hash of D is also index 3. So what happens when you check index 3? Muingon si D, uy, diri man unta ko pero ngano naaman si letter A. So that means there is something that happened. There is a collision. D, who was supposed to be in index 3, is already occupied by index A. So what happens? You will go to the next available cell. So mura siyag nagsulti nga, uy, diri man unta ko pero occupied naman. So adto na lang ko sa sunod. So ni adto siya sa sunod sa letter C or sa index 4. Pag abot niya sa index 4, kita siya letter C. Di man gihapon siya maka-insert sa letter C kay di man siya pwede mangilog og space. So what happens? It goes to the next available. And now it's inserted at index 5. So take a look. D was supposed to be in index 3, but because of the collision here and here, we reach index 5. What do you call when a value or an element has the same hash value? Think of them as synonyms. Pwede pod brothers, but they're actually synonyms. So A and D are synonyms. They have the same hash value. So, what happens when I try to insert letter E? So insert letter E, hash of E is 9. So what happens? B or E tries to go into index 9. Pag abot niya sa index 9, uy, naanamay nag-occupy sa index 9. Therefore, it tries to go to the next available space. But if you take a look, my array only reaches index 9. Where is the next index? Or where is the next index? You go back to the top. Familiar? It should be, because this is an implementation using circular array. So, because B occupied index 9, we had to go to look for the next available slot. And in this case, it was index 0. So si E, naabot sa index 0, kita sa, uy, di ba ni occupied, diri na lang ko mo pwesto. So the logic for closed hashing is very simple. Insert into the element or to the index where you hash at. So insert A at index 3. If there is no element that's already there, insert. If there is, go to the next available cell and keep going to the next cell until you find an available space. Ingon ana ra gyud siya ang algorithm. So if we go to F, we'll try it again. F is supposed to be at index 0. F is supposed to be at index 0. But if you take a look, F is supposed to be at index 0, pero naanay si E. So that means there is a collision, and that means F has to find another place. So the logic is, uy, naana may E, balhin na lang ko sa next, which is 1. 1 was available, so dito siya ni pwesto sa index 1. Now, there is a new term here, displaced. So, we will define that in the next slide. So, when two or more elements have the same hash value, we call them synonyms. So, in this specific scenario, our synonyms are A and D, as well as B and E, because they had the same hash values. So, unsa din si displacement? Displacement happens when an element cannot be stored in the position returned by the hash because, and the keyword here is non-synonym. So, displacement only works for non-synonyms. So, in this case, kaning si F. F supposed to be at index 0, but there is an E there. And E is supposed to be at index 9. But because na siya collision here, nabalhin siya dire. F is at index 0, but he couldn't be inserted. That is what we call a displacement. Naay nangawat sa iyahang pwesto nga dili niya synonym. So in that case, F cannot be stored at index 0 because it was displaced by a non-synonym letter E. So mo na siya, displacement. Collision is if same sila og value here. Naigo sila. So collision is an event when an element is attempted to be inserted at a position returned by the hash function and the position is already occupied by another element. So, if mahog nga synonym sila, mo collide sila. If di gani, na-displace ang katong element. So, what is the solution? That is what we call linear hashing. So, what we did a while ago, wherein we tried to go to the next element and try to search for the next available element, mo na itong ginatawag na linear hashing. It's a solution to collision wherein the element is placed in the next available position in the circular array. So the formula for that is hash for the value of x is equal to hash of x plus I. I is just an iterator. Modulo max, because we're using a circular array, remember we will do modulo max, wherein max is the size of the pre-allocated space. Because otherwise, we wouldn't be able to use this as a circular array. So for example, in this case, we have 0 to 9. 10 ang atuang max. There are 10 elements max. So if we reach 9, 9 plus 1 is 10. 10 modulo 10 becomes 0. So that's how we go back to the start. So in this case, h of D3 is a collision. So hash of D3 was a collision. So, we did the formula. Why I is 1. Ngano I starts at 1? Ngano dili 0? It's because if you start at index 0, the formula will still give you h of d, which is 3. 3 plus 0 gives you the same index, which is 3. So it means start at the next available element. So 3 plus 1 modulo 10 is 4. 4 was already occupied. So go to the next index. Index is now 2. 3 plus 2 modulo 10 is 5. 5 was not yet occupied, therefore I was able to insert at 5. Very simple, no? Just iterate until you find an unoccupied space. Very simple concept, linear hashing. Or I would call this linear probing as well. So hashing, probing, similar terminologies. So let's go to operations. Let's try to do the member operation or the search operation. So take a look at the function call. Member receives an element and the dictionary to search. So the formula or the process for this is very simple. Call the hash function and until you find the element or until nakatuyok na ka, you will be able to find it. So in this case, take a look. H of C is equal to 4. C was found at index 4, so C is found. Next, member G. G returns a 1. Pag tanaw niya sa index 1, F man ang sulod. Therefore, meaning wala si G. Wala na siya ni tanaw sa previous elements. It just knows that G did not exist here. Take a look at what happens next. Delete letter C. So, to delete something, or to do any of the operations rather, you always need to do a hash because the hash tells you where the element is located. So, delete C4, na-delete na ni nato si index or si value C at index 4. We're doing this because we want to prove a point. Let's keep going. Member D. So, we're looking for letter D. And D is at index 3. D is at index 3, but wala man si D sa here, wala man si D sa letter A. So, we try to go to the next 4. Wala man nakit andere, so niadto ta sa next. D is now found at index 5. Now, do you notice something weird? Ni continue ta bisag na ay ni stop. But in the case of G, we didn't continue here at G. We were because of there's an F there. How do we know when to continue and when not to continue? That's a problem. What did you observe? This would have been so cool if we were in class. I would have been doing the microphone thing. What do you observe? Like, think about what you observe. We're looking for J. J is supposed to be at index 3. How do I know when to stop? Mura siya ginganana tong concept. So, based on the observation, it is best to differentiate an empty from a deleted cell. Because we wouldn't know when to stop looking for an element if dili ta kahibaw if naay na delete nga cell or if empty lang yun na siya in the first place. So we need to change the implementation such that instead of showing the cell is empty or it's just showing a blank thing there, we need to differentiate empty versus deleted. That way, we would be able to know whether we continue to search. So, for example, kanina we were looking for the letter G. Kung imata-mata na to, kahibaw ra gyud ta nga walay letter G. But we knew that G was supposed to be at index 1, pero wala man siya dito. So, logic would define we would try to look for it there. But in this case, we can stop. But here, we were looking for D. D was supposed to be at index 3, but because Okay, so D was supposed to be at index 3. So we check the next. Sa una, makaabot ta ni letter D because letter C was here. But for some reason, wala naman si letter C dire. So, we would have ideally stopped at that point. Kaya wala naman ta nakakita sa element. So, maglibog ka, when do I actually stop? That's why we need to introduce our empty and our deleted. So, in this case, we only stop when we actually find an empty cell. So, kanina, si G. We were looking for G starting at index 1. F is not G, so I go to the next. Is it empty? If it's empty, stop looking. Wala na gina si G diha. Now, we deleted letter C, so it's deleted here. And we look for member D. So D is supposed to be at index 3. So ni-check siya, D is not A, so I'll go to the next. Deleted is not the same as empty, so there was something here that could have displaced my D or collided with my D. So I go to the next. D is found. So you only stop if the element is found or if you find an empty cell. Don't look or don't stop when you find a deleted, because it's possible that there was a collision or displacement that occurred that moved the cell you are looking for. That's why you need to stop after you find an empty, not when you find a deleted, which is the importance of differentiating our empty versus deleted. Simple, no? So based on the illustration on the left, write the definition of the data type dictionary implemented using closed hashing. You can define empty and deleted macros representing empty and deleted cells. Do you know how to define macros? Yes, you do. So, kamo na'y bahala unsang inyong i-macros for empty or deleted, but essentially every time you delete, you change it to deleted. When you initialize, set everything to empty. So, kamo na, asynchronous man taron, so I would suggest you guys try to do these functions or these operations. So initialize sets all of the elements in your dictionary to empty. Member checks if the element is found. We should also actually look for you should actually create the hash function as well. So, unsa man gini atong hash function? I'm not actually sure what this hash function is. Imata-mata daw na to. Letter A. Small a is 97. So, small a is 97. Ngano nakakuha kog value nga 3? Is it modulo 10? No, it's not. So I'm not actually sure what the hash function for this is. I'll probably look into this more and let you know. So you'll need to do initialize, member, insert, and delete. I wonder if you could figure it out yourselves, and I think GPT can do this. Why don't we try and test the limits of our amazing GPT? So let's try. Technology. Given these hash values and a dictionary that can store up to 10 elements, what is the potential hash function? So it doesn't match, which is what I notice. Maybe it subtracts something like a or multiplies by a small constant. It still doesn't fit. So it's trying to figure it out. I don't think it can figure it out. Oh, okay. So apparently ChatGPT can't find it out. So let's, yes, try. So while it thinks about it, just try to start by looking into implementing these. Regardless of the hash though, it will still, regardless of what your hash will be, collision will still occur. Collision will still occur, displacement will still occur. So you don't really need to overthink about the hash because the hash doesn't change anything with what you do with initialize, member, and insert or delete. It just tells you where to insert the value. The logic will still say the same. So if ChatGPT can't figure out what the hash formula was, then just come up with any hash. You can even do something as simple as the hash is just modulo 10 of the given ASCII of A. So if A is 97, modulo 10 of that is index 7, so I'm going to store that at index 7. Doesn't have to overthink it. So, also think about the advantage of closed hashing over open hashing and vice versa. The advantage of open hashing over closed hashing. Nah, I accidentally showed the next slide. Never mind. Because I accidentally showed the next slide, let's just talk about the advantages. Of hashing Redini, very good. So, the advantage of hashing is that it's constant time per operation on the average. So, constant time is O sub 1. No requirement that the set be subset of any particular universal set, meaning we're not stuck with having to have, let's say, a universal set that contains all numbers from 0 to 100. It can be any value. And the worst case, your hashing requirements time proportional to the size of the set for each operation. Very confusing, Paminano. Hashing requires time proportional to the size of the set for each operation. It's essentially depending on the size of the set. So if the set has n elements, it's proportional to n elements. So it's an O sub n. Worst case. So na tayong mga exercise, insert the elements, blah, 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 blah. We can do this in class. Things to think beyond: what is the perfect hash function? How does the hash function contribute to the effectiveness of hashing? What is a load factor and how does it affect the performance of hashing? What is the relationship between packing density and collision? Are they directly or inversely proportional? And what is the Poisson distribution? Char-chara na ako ambot if mo bagyo na ang pagsulti. But I think that's French. So that's the end of the lecture. Answer to the exercises are as follows. I kind of give. Never mind. Basta mo na siya the end. So today we learned about closed hashing. For our next lecture, we will discuss the different variations of closed hashing. If you have any questions, do let me know. I really hope some of you guys try to code this one in general. Kani silang upat. Because you will really be able to appreciate closed hashing and open hashing once you are able to code them. But first, let's go back to GPT if they have figured out this one. Oh. So, ChatGPT couldn't figure it out. So, ang iyang ginabuhat, naghimo na lang siya og hash map, meaning 0 will always map to 3, 1 will always map to 9, 2 will always map to 0, 3 will always map to 1, and so on. So, I don't know the hash function. GPT doesn't know either. So, it doesn't matter. Just remember, when you initialize, set everything to empty. The hash function will just be a modulo 10 para sa yun lang. ASCII of the value, modulo 10. Insert will insert there, delete will delete the element. So, mauna na siya for today's lecture. Thank you everyone and see you next week.